Okay, Assalamualaikum warahmatullahi wabarakatuh. So we meet again for PST371 Plastic Fabrication. For Chapter 6, we will cover the blow molding processes. I think here we will cover two types of blow molding, which is extrusion blow molding and injection blow molding. Okay, as usual, the learning outcome, the first one to identify the three blow molding process in the production of plastic products, describe the process stages involved for blow molded product fabrication process and the raw material requirement. Explain the comparison between processing product features of methods of blow molding technique. Okay. Some introduction for blow molding. Okay. Blow molding, also known as blow forming, is a manufacturing process by which hollow plastic parts are formed. It is a process used to produce a hollow object from a thermoplastic. So basically, blow molding is a process of blowing a plastic material to produce a hollow object. Okay. Other than blow molding, we have also rotational molding to produce hollow parts or the hollow objects. Okay. So next, in general, there are three main types of blow molding. Okay, first one is extrusion blow molding. The second one is injection blow molding, and finally the stretch blow molding. I think extrusion and injection machine is similar. Like previous chapter, I did cover on extrusion and injection. However, they include the blowing process for manufacturing of hollow parts. However, the stretch blow molding slightly differ or have some additional processes in order to have a better products quality as compared to extrusion and injection blow molding. Later on, I will discuss the advantage and disadvantage of these three types of blow molding. Okay, the blow molding process begins with melting down the plastic and forming into a parison or preform. Okay, basically, most of process of manufacturing a plastic material involving by the melting down your plastic material. In terms of the molten plastic, for a blow molding process, you either need to produce parison or preform. What is parison? Parison is a tube-like piece of plastic with a hole in one end and in which compressed air can pass through. Okay, whereas the preform is a free-falling, what we call that extruded parts. Okay. The basic process has two fundamental phases. One, a preform or parison of hot plastic resin is somewhat tubular shapes is created. A pressurized gas, usually air is used to expand the hot preforms and press it against a mold cavity. The pressure is held until the plastic cool. Okay. Later on, I will mention which machinery or the process using a preform and which one using a parison itself. Okay. Then this section identified another common feature of blow molded article. Part dimensional detail is better controlled on the outside than on the inside, where material wall thickness can be altered the internal shapes. Okay. Once the plastic has cooled and hardened, the mold open up and the part is ejected. Basically, this is the whole process of blow molding process, either injection, extrusion or stretch blow molding. Okay. So we go through the first one, the process involved with the extrusion blow molding. Okay. Extrusion blow molding is a process that creates hollow parts. There are two different industry segments that use extrusion blow, including packaging, which is bottle, industrial, and any parts that are not bottle. Okay. So extrusion blow molding is a process that can make small to large hollow part quickly. This is the keywords of the extrusion blow molding. You can make either very small or very large hollow part very quick. The production range from less than 1 ounce up to 1,000 gallon. Some current products are container, gas tank, toy, seat bag, air truck, 55 gallon drums. Okay, even drums, polymer drum is made from the extrusion blow molding. Okay, the working principle for extrusion blow molding start with the process start with the formations of the hollow parts of plastic called a parison. So what did you need is a parison. For extrusion blow molding, you use a parison. Later on, for injection and stretch blow molding, we will take a look. Either they need a parison or a preforms. Okay. The tube is extruded downward until it extends past the bottom of the mold. So you extrude the polymeric material, the molten polymer, until it extends past the bottom of the mold. Okay, and then the mold close on the parison so that you seal the other ends of extruded parts. Okay, then the air is introduced into a parison via a blow pin at the tops of the part or a needle in the middle of the part, inflating the plastic and pushing it against the wall, the mold side. So as you close the mold, you seal the whole what we call that the hollow parts, okay, the extruded parts, and then you introduce either onto a tops of the extruded part or by injecting a needle to push the molten plastic against a mold side so that it can blow, take the shapes of the cavity. Then the part is allowed to cool in the mold, okay, and finally the part is ejected from mold. So basically, this is the working principle of the extrusion blow molding. Okay, this is some of the illustration of the whole process that I mentioned earlier. So you extrude your parison, okay, your parison into a mold, and then the mold is closed, clamps the parison. Then you introduce air. In this case, you introduce at the tops of the parison itself, and you allow it the air pressure to press against your molten polymer towards the cold mold cavity, and after it's solidified, the mold is open and the part is ejected, and you produce a hollow parts of plastic material. This is some of the illustration again. And then we have the parison is continuously extruded through the cycle. It can only be used with material that have good melt strength. It also can only be used for short cycle time. So only a specific material can be used for extrusion blow molding. The first one, you need to use a good melt strength polymeric material. So either you modify, you add some fillers, or you adjust the processing parameters. Okay. So this is, I think the illustration should be. I think later on you take a look at this slide that I given to you. There's some video that I include on the process of manufacturing, or the process of involving making the parison or the preforms. And then we have the intermittent extrusion blow molding. The plastic material that is extruded is stored in an accumulator. When the mold open, the accumulator push the material out of the die to form a parison. Okay, it is used for parts with long cycle and material with low melt strength. Okay, the plastic material that is extruded is stored in accumulator to retain its what we call that semi-solid shapes. Okay, there are two ways to get air into the parison. Either the one is blow pin are used to bring the air in the parting lines of the mold. In the bottom, it is inserted through the neck. Second one is blowing needle are used to create a very small hole in a part. Such a pin can be located anywhere in a mold. The plastic material expands through a thickness as it exits the die. This is called the die swell. Okay, this is very common with the plastic material. Although each of the plastic material have a different expansion or the swelling properties, However, you need to take a consideration and you need to have a knowledge with the shrinking and the swellings of the material. It expands because of plastic membrane. The plastic material is squeezed as it goes through the land in a blow molding die. As it exits, it wants to go back to the shape it had before it went through the land. During the formation of person, it gets longer and heavier. As it gets heavier, gravity starts to extend the person and it called the person sag. So that's why when you extrude the person, that eventually the longer the person will be a sagging area. So it called a person sag. This creates an uneven wall thickness in the person. That's why you need to have a very good melt strength, okay, for the extruded parts or the raw material to be used as the extrusion blow molding. Material with high melt strength are needed in extrusion blow molding to reduce the amount of sag and excess thinning in a person, which is the lower barrel temperature that injection molding are used to increase the viscosity. Wide spec or higher molecular weight grades are used to give a person more strength to hang without tearing or excessive sagging. So you need to consider these two types of parameters, or the material spec need to be used for extrusion blow molding. This is the common material that being used for extrusion blow molding. For polyolefin, we use polyethylene, and polypropylene. For polyethylene, we have different molecular weight. So some of the polyethylene grade are very suitable for extrusion blow molding itself. Whereas we also have thermoplastic elastomer for extrusion blow molding, and also a polycarbonate is known as having a good melt strength properties. Other than that, we have a PVC material. Some of the PVC require some plasticizer to promote better flow properties. However, you need to take account more amounts of plasticizer will reduce the melt strength properties of the polymeric material. For key processing parameter, the first one is melt temperature. Change the viscosity of the material. Some of the parameter that you need to consider that is important is a melt temperature itself. So previous semester, I think you did cover on plastic material. So on plastic material, you did learn about the melting temperature for each of the plastic material. So you need to know the working temperatures of each of the material itself. And then as through the speed, determine the speed of the person is made. And then we have a blow time. Although blowing from the product, holding pressure on the product, keep it contact with the bowl, it increase the cooling. And then we have a blow pressure, help to pick up surface detail in the mold. If you have a delicate details of your mold or the cavity, you need higher blow pressure. Okay, present drop time, how long the present hang and stretch before the mold can be closest. And then person programming, create local thickness changes in a person. If the person is off-centered, it will cause thickness variation around the circumferences of the part. So you need to know the thickness when you produce a person. Process advantage for extrusion blow molding. Mold are inexpensive versus the injection molding. Okay, since the molding pressure are much lower and tooling can be produced in aluminium. So as compared to injection molding, so you need higher pressure for processing, and because of the higher pressure, you need hardened steel for produce your using hardened steel material to produce your mold. This is different with the extrusion blow molding. Irregular geometry can be easily molded if the mold can open without destroying the parts, and then there is the ability to combine several components into one part. Okay, this is the most unique properties for extrusion blow molding as compared to injection blow molding. The inside volume of the part can be filled with foam while the mold is still closed. Okay, so some of the process of extrusion blow molding, they include with the fillings of the material itself. Sometimes they put the liquids, the water, the detergent, whatever it is, so that the end process of filling the material into a bottle being eliminated. Okay. However, it also have a disadvantage. The secondary operation are always needed to remove flesh. As we know, the hole and the other feature are put in after the part is removed from the mold. As we know that you extrude your person above the bottom mold, so that when you clamp, there is a flashing that you produce during the process. So you need to trim after the process is complete. There is a wall thickness variation because of present sag and part shapes. The part tend to be thinner on the top because of sag. This is the issue with the sag point. So the sagging properties of the person reduce the produce extruded blown parts with a thickness variation. Usually the top area will be thinner, the bottom part will be thicker. Okay, that's why some illustration I would love to show you. For example, this water bottle use the extrusion blow molding itself. So extrusion blow molding, if you notice, the bottle is made for this extrusion blow molding, having a thinner thickness at the bottom, at the top, while thicker at the bottom. If you you can do some testing. You cut this bottle to half, and then you will measure the thickness using a thickness gauge, and you will figure out that the thickness at the top will be having a slightly thinner as compared to the bottom parts. Okay. And then when the part have a bigger local diameter, the part will be thinner in a thicker region. Okay, the further the person has traveled, the thinner it gets. Okay, although you can produce a very large component, but it will having difficulty to have a consistency in thickness of your extruded parts. Any surface defect that result from the extrusion of the person or sweating from the mold will cause surface appearance problem on the part. If there is a change in apparent thickness or in the pinch off is not designed correctly, there could be a weak weld leading to part failure. Okay, this is the common defect that you see in extrusion blow molding parts. So you will need to encounter it if you having this issue during the production. So you don't want to produce a more defect during the production line. This is some of the illustration that being bottles that being extruded using extrusion blow molding. The second process is the injection blow molding. Okay, the injection blow molding phase consists of the injection molding of thermoplastic material into a hollow tube-shaped article called a preform. Okay, different from the extrusion blow molding. Okay, extrusion blow molding you have a person. Okay, for injection blow molding you have a preform. You need to inject the preform to produce a tube-like article. Again, the preform is transferred into a metal shank called the core rod into a blow mold. Okay, the process of injection blow molding or IBM is used for the production of hollow plastic object in a large quantity. If the IBM process, the polymer is injection molded onto a coffin, then the coffin is rotated to the blow molding station to the inflated and cooled. Okay, the process having a different mold. So you inject the molten plastic into a mold to produce a what we call that preform first, and then the preform will move to the other coffin for the blowing process. This is the least use of the three mold blow molding process, and is typically used the mixed mold medical and single serve bottle. Okay, among all of the three types of blow molding technique, injection blow molding is the least used. However, later on I will mention what's the advantage using these types of injection blow molding. The process is divided into three steps: injection, blowing, and ejection. Okay, this is the illustration. So firstly, you inject the raw material into a cavity to produce a preform, and then you move your molded, injected molded preform upward, and then you close with the other mold before you can blow molded, and finally the hollow part produced can be ejected. Okay. This is This is the illustrations of the preform itself. So the injection molding machine will produce the preform before it can be blown to produce hollow parts. Okay. Okay, this is the complete 2D illustrations of the injection blow molding. Okay, over here you have the first section. Okay, the raw material will be melted into injection screw parts. Okay, and then you will eject the molten polymer into a cavity of the mold to produce a preform, and the preform will be rotated, moved to the blow mold station, and it will clamp with the mold and allow the preform will be blow to take shapes of the cavity, and finally we move to strip the blow molded parts. Okay, this is some of the illustrations. Firstly, you inject the raw material or the molten plastic into a cavity to produce a preform, and then the preform will be removed and moved into a pin for blow molding process. Over here, blow molding mold, and you inflated the preform to take shapes of the cavity, and finally the part will be ejected. Okay. This is the multi stations, or we call that multi-cavity of the injection molded part. For you can see here the process of injection molding involving process of four preforms. Okay, with one single injection. Okay. And then the preform will be rotated into station 2 for blow molding process. Okay, blow mold, and then finally the station 3 will be the stripper ejection. So at one cycle you can produce 4 bottles. Injection blow molding is a part of injection molding and a part of blow molding. With injection blow molding, the whole plastic material is first injected into cavity where it encircles the blow stem, which is used to create the necks and establish the grams weight. And then the injected material is then carried to the next station of the machine, where it is blown up into a finished container as in the extrusion blow molding process above. Okay. The molten polymer is fed into a manifold where injection through nozzle into a hollow heated preform mold. The preform mold form external shapes is clamped around the mandrel, which is the core rod, which forms the internal shapes of the preform. The preform consists of fully formed bottle or jar neck with a thick tubes of polymer attached, which will form the body. The preform mold open and the core rod is rotated and clamped into a hollow chill blow mold. Okay, this is the second process. The core and rod open and allow compressed air into a preform, which inflates it to the finished article shapes. After cooling periods of the blow mold opens and the core rod is rotated into ejection station. So this is the third process. The finished article is stripped off the core rod and leak tested prior to packaging. The preform and the blow mold can have many cavities, typically 3 to 16, depending on the article size and the required output. There are 3 sets of core rods which allow concurrent preform injection, blow molding, and ejection. Okay, the advantage of injection blow molding: scrapless process, meaning no flash to trim and no regrind. This is the comparison with the extrusion blow molding. Typically suited for container of 5 liter and smaller. So as compared to extrusion blow molding, you can extrude blow parts which is very small to very large. However, the IBM injection blow molding can only produce a 5 liter and smaller parts, okay, capable of running a wide range of material because we don't require the material to be hanging or any issue with the sag point. Okay, high quality injection molded neck finish as compared to the extrusion blow molding. But the disadvantage, very high tooling cost per container, typically cost 40 to 50% of the machine cost. Difficult to run co-injection of multi-layer. Okay, this is the disadvantage compared to the extrusion blow molding. At the minimum cycle time, typically 15 seconds. It looks like it is very short a process. However, the extrusion blow molding can achieve below than 15 seconds. Cannot do handle wear. Okay. Also, same as comparison to the extrusion blow molding. Extrusion blow molding can produce hollow parts with the handle wear. The disadvantage of IBM compared to its extrusion-based competitor, the injection blow molding process has a lower production rate, which explains why it is less widely used. Okay, injection blow molding is generally suitable for smaller container and absolutely no handle wear. Extrusion blow molding allows for a wide range variety of container shape, size, and neck opening, as well as the production of handle wear. Extrusion blow molds are generally much less expensive than injection blow molds and can be produced in much shorter period of time. Finally, we go to the third blowing process is the stretch blow molding. Stretch blow molding, in short, is one of the in which injection molded process is first used to get the plastic frame as a shape called as preform. The preform have shapes which include the top as well as the end parts of the container. Okay, so the stretch blow molding is imitation of the injection molded process itself. Okay, so for IBM injection blow molding and extrusion blow molding, they use a preform. Okay, for extrusion blow molding, they use a parison. Stretch blow molding is a method of producing a plastic container from a preform or parison that is stretched into both that hoop direction and the axial direction when the preform is blown into the desired container shapes. Okay, excuse me. And then the stretch blow molding is possible for various thermoplastics such as acrylonitrile, polystyrene, polyvinyl chloride, polyamide, polycarbonate, polysulfone, acetyl, and polyethylene terephtalates. Okay, so wide range of material. So basically, this is the illustration of the extrusion, stretch blow molding. So as I mentioned earlier, you use a preform or the parison itself. Okay, so here the parison that you have a mandrel, the mandrel will push your parison until it stretch, and then you pressurize with the air so that it can take shapes of the cavity, and then it's allow it to cool, and finally the part is ejected. The stretch blow molding process, the plastic is first molded into a preform using injection molding process. This process are produced with the necks of the bottles, so you need to have a delicate details of the. You will have the delicate detail of the necks for the bottles. The preforms are heated typically using infrared heater above the glass transition temperature. So you soften the preform itself, then blow using high pressure air into bottle using a metal blow molds. Usually, the preform is stretched with a cold rod as part of the process. In a single stage process, both preform manufacture and bottle blowing are performed in the same machine. Okay, this is the illustration. You have a preform and then you have a mandrel. And then as you heated your preform, and it reached the glass transition temperature, the material will push your softened preform, and eventually you will blow the preform, the softened preform, and it allow the preform to take shapes of the cavity, and it will cool in a cool mold, and eventually it solidify and the part can be ejected. Okay. Advantage of stretch blow molding include low tool and die cost, fast production rate, ability to mold complex parts, produce recyclable parts, increase the material tensile strength, barrier properties, and clarity because they stretch from both directions. Okay, vertical and horizontal. Reduce weight stretch blow molding process produce a container from less raw material and will improve economic and water properties. But the disadvantage, limited to hollow parts, and wall thickness is hard to be controlled. I think that's all for chapter 6. I hope to see you for chapter 7. By then, if you have any question, please feel free to ask me in a group. So I hope to see you next week for chapter 7. By then, Assalamualaikum warahmatullahi wabarakatuh. Thank you.